When we look at geological features around the world, many of them are radically different from anything being formed today, like thick mud layers over continents, or coal seams covering entire states, or fossil graveyards, or frozen mammoths, or miles of underground cave passages, or thick ice sheets moving over continents, or craters of supervolcanoes, or canyons cut thousands of feet deep. It looks like the present is not the best way to explain the geological features of the past. The Bible, however, offers another way to explain features from the past. Noah's flood was a global judgment, a violent catastrophe upon the earth. Based on this truth revealed in God's Word, scientists are developing a series of models to explain how the flood and its aftermath could have shaped the world today. In the course of the flood, erosion washed away mountains of rock in some places, while miles of mud and sand were piled up in others. The Earth's crust was thickened in some places and thinned in others. Like jostled ice cubes sink and bob up to their proper level in the water, some sections of land sank after the flood, while other sections rose. Supervolcanoes and superquakes rocked the world after the flood. As the centuries passed, the catastrophes became rarer and smaller. Modern earthquakes and volcanoes are dim leftovers from this violent period of Earth history. Warm oceans after the flood produced violent weather, possibly even hypercanes, huge hurricanes like the Great Red Spot on Jupiter, which may have persisted for centuries. High rainfall after the flood filled enormous lakes, eroded large canyons, and carved cave systems. As animals left the ark, multiplied and spread over the earth, many of them were preserved as fossils. Some were buried in ash and mud. Some were preserved by unique chemical conditions, and others were frozen. Truly, the present is not the way things were in the past. Instead, the Bible is the key to help us understand geological features around the world. On May 18, 1980, Mount St. Helens, located 95 miles south of Seattle, Washington, erupted. The eruption was triggered by an earthquake centered beneath the mountain that measured 5.1 on the Richter scale. The lateral blast swept out the north side of Mount St. Helens at 300 miles per hour. With temperatures as high as 660 degrees Fahrenheit and the power of 24 megatons of thermal energy, it snapped 100-year-old trees like toothpicks and stripped them of their bark. Before the famous eruption at Mount St. Helens, scientists were mostly familiar with slow-acting examples of geologic change. But at Mount St. Helens, geologists watched the Earth's surface change quite rapidly. Icebergs were buried in hot avalanche material. They melted and formed badlands in days. Eruptions on May 18 and June 10 produced fine layers in hours. On June 10, mud flows cut zigzag canyons 100 feet deep in soft sand and mud, complete with perpendicular side canyons. Canyons that are reminiscent of the geography of Grand Canyon, only 40 times smaller and clearly produced within hours. Mud flows over the following decade cut hundreds of feet into solid rock in just days of cutting time. Fallen trees formed a log mat on the surface of Spirit Lake and dropped bark to the bottom of the lake, accumulating up to 3 feet of bark peat in just a couple years. And vertically floating logs sinking to the bottom of the lake resulted in buried trees in only a decade, similar to the trees of Yellowstone's fossil forest, which are also buried in volcanic layers. Even though Mount St. Helens is a very small catastrophe compared to the flood, or the major catastrophes immediately following the flood, it provides a better clue to what happened in those times than the slow geologic processes which are most commonly seen in the present. Rock layers are visible in mountains, plateaus, and canyons all over the world. Where did these rock layers come from? Present processes aren't the answer. Today, sand and mud are usually deposited in thin layers along the outer edge of continents, and the formation of fossils today is rare. But somehow in the past, thick layers of sand and mud were spread across entire continents and filled with well-preserved fossils. Noah's flood suggests a way to explain these puzzling features. Flooding the continents, for example, could carry sea creatures many hundreds of feet above present sea level. Andrew Snelling is a PhD geologist from Australia who has spent over 30 years studying rocks, working in the field and in the lab.
We find marine creatures buried at the top of the Grand Canyon, which is over a mile above sea level.
A global flood could carry sand and mud enormous distances.
Some of the sand grains that are in the Navajo sandstone had to have come from the Appalachians. But what river or what process today is carrying material from the Appalachians to the southwest?
A global flood could quickly lay down thick layers of mud and sand, burying even giant animals and tall trees.
We've got coal beds with trees sitting on them, and these trees, tree stumps, go through many strata, which means that before they could rot, you had to have lots of sand and mud coming in quickly. Several places in the Grand Canyon, 4,000 feet of different types of sand and mud and lime have been bent, and they've been bent while they're still soft. Both the bottom layer and the top layer are all bent the same way, which means that the whole sequence of 4,000 feet of sand and mud and lime had to have been laid down very quickly by the waters and then bent very soon afterwards.
A global flood could form thick layers across entire continents.
In the Grand Canyon area, we've got limestone bed, the red wall limestone. The same limestone can be found over here in the eastern United States.
A global flood could cut deeply and widely.
We've got this huge flat surface at the rim of the Grand Canyon, which goes for thousands of square miles, where waters on a great scale over a vast area just swept over it and swept everything clean.
None of these processes, deep, wide erosion, or thick, rapid layering, or continent-wide distribution, or lifting of marine organisms above sea level, or sand carried across continents, occur in the present. Radically different processes are required, such as occurred during Noah's flood. Dead organisms usually don't last long. Scavengers and bacteria consume them quickly. Soft tissues rarely last more than days or weeks, and hard parts like bones or shells only a month or two. But the rocks of Earth contain billions and billions of fossils, and in many places, millions of fossils are exquisitely preserved, even soft parts. How could this be? To preserve a body, it needs to be put in a safe place. Extremely cold or dry places would protect them, but most organisms don't live in those conditions. There is another solution: rapid burial. If a body is sealed from oxygen and out of reach of burrowing animals, then it has a good chance of fossilizing intact. Rapid burial is uncommon today, but there's much evidence of massive burials in the past. Not only are many fossils well preserved, they're found amidst very fine sediment layers. Fine layers rarely last in the present because all sorts of animals are digging around in the mud and soil, searching for food. In just a few weeks or months, the original layers are destroyed. But in the fossil record, churned up sediments are rare. If these sediments were laid down rapidly, however, they'd prevent burrowers from doing their job. And there are thousands of feet of such layers in the fossil record all over the world. This suggests that moving water laid down mud and sand rapidly over a wide area, and the process lasted several months. A year-long global flood, as described in the Bible, is the best explanation we know for the well-preserved fossils and fine layering throughout the rocks of the Earth. Coal appears in vast deposits scattered over the continents. It is typically thought that such deposits require many thousands to millions of years to form. 10 feet of plant material is needed to make 1 foot of coal. Evolutionary geologists teach that most coal deposits are basically a result of peat building up in swamps over millions of years. And since peat accumulates very slowly in modern swamps, long periods of accumulation would be required at modern rates. But forming coal this way has problems. For example, the top and bottom of coal seams are usually flat, and thin layers of mud are often found within coal seams. In the present world, however, roots of plants in the swamp break up the peat layers and mess up any mud layers which might form. Tree trunks especially penetrate the swamp peat, making it very uneven. Apparently, no modern process can explain how coal originated. The flood of the Bible, however, may provide an explanation. In the course of the flood, weeks of unceasing rains eroded away soil and plants, and rising seas and tidal waves destroyed the forests of the world. Some plants would be buried in place. Some would be ground up and destroyed. Most, however, probably floated atop the floodwaters until they became waterlogged and sank to the bottom. A continuous rain of sinking plants could produce the thick layers of plant material needed to form coal beds. Undisturbed by growing plants, such layers would have flat lower and upper surfaces, and in between could be undisturbed layers of mud. Bark rubbing off logs would explain coals made of bark. And vertical trees sinking would explain stumps sitting atop coal layers without penetrating them. Both have been observed at Mount St. Helens. The flood provides an explanation for the origin of coal, consistent with an Earth only thousands of years old. The enormous coal reserves on our planet are a reminder and tribute to a beautiful and bountiful world now lost. The Earth's surface is scarred by deep canyons, cut into solid rock. But how did they form? A little bit of water over a long time, or a little bit of time with a lot of water? Modern rivers don't generally cut downward into solid rock, so today's river erosion seems incapable of explaining rock canyons. The Great Flood of the Bible, however, provides a possible explanation for such canyons. In soft mud or sand in your own backyard, you can see the power of heavy rains on a small scale. A rainstorm can create miniature canyons in only minutes. Though these canyons are very small, cut into mud, they share many of the same characteristics as the world's great canyons. On a larger scale, mud flows have also been observed to form these features quickly. At Mount St. Helens, a single mud flow off the mountain carved Engineer's Canyon out of soft sediment in a single day, 100 feet deep. And the same thing even happened in solid rock. A series of mud flows created Lewitt and Step canyons on the front face of Mount St. Helens, cutting hundreds of feet into solid rock over just a few years. We observe canyons being cut into rock today, but only by catastrophic processes. Just imagine how easy it would be to cut massive canyons during and after Noah's flood. Torrential water and mud flows, followed by uplift and heavy rains, created the right conditions to produce the world's canyons. Furthermore, it may have been easier when flood sediments had not fully hardened. Grand Canyon is a good example where we find evidence of catastrophic forces at work. Upstream is evidence of huge lakes. These lakes would never have formed if the canyon were already open below them. However, if these lakes had formed from rains after Noah's flood, and if the pressure of these waters broke through and carved through the recently deposited sediments, then we would expect to find surge deposits downstream. Below Grand Canyon, this is precisely what we find. Evidence of a lot of water cutting over a little bit of time. Camels and llamas, so different and living on different continents, yet able to breed together and produce young. Examples abound of species that can be bred together. Zebras with horses, tigers with lions, potatoes with hot peppers, and so on. This amazes biologists. Based on modern rates of change, new species should quickly lose their ability to interbreed with other species. So, modern species that interbreed must have formed recently and rapidly. It's amazing that camels and llamas, though separated by oceans and thousands of miles, came from the same parents in relatively recent times. So how could such major changes have arisen so rapidly? This is a mystery to biologists because they don't see such widespread rapid change today. And they don't know of any natural process that can create the biological information necessary for such changes. The biblical account of creation may provide the answer to this mystery. Breeders have long known that domesticated plants and animals possess a huge reserve of information that can produce a stunning variety of shapes and functions. Most modern dogs, for example, came from just a handful of breeds in the 1600s. And these dogs have a wide range of features that suit them for a wide variety of environments, from sledding at the poles to hunting in the desert. And none of that variety was put there by humans. The information was already built into the dogs. Such variety of information can be found in cattle, pheasants, pigeons, apples, orchids, and many other domesticated plants and animals. If all the non-domesticated animals on the ark had this same wealth of information, then we could understand how a single pair of cats could produce all known cats. Today, crossbreeding between domestic cats and wild cats, between cougars and leopards, between lions and tigers indicate that all modern cat species are the same created kind. The original cat kind carried all the information necessary to build the variety of cats we see today. But where did this information come from in the first place? The Bible reveals that God created all the animal and plant kinds in the beginning. And we're now learning that God placed a huge amount of information within each created kind, allowing them to diversify into the myriad of plants and animals we see today. The information was there, all there, right from the start. This is not evolution from a lower form of life. It's creation by an all-knowing, all-powerful, infinitely wise Creator who is worthy of our worship and praise. The distribution of wildlife poses some puzzles for modern biologists. Why do we find giant land tortoises on islands in the Pacific Ocean and 10,000 miles away in the Indian Ocean, but nowhere in between? Why do we find identical plants on either side of the Atlantic Ocean? These kinds of disjunct or split ranges can't be explained by the way organisms travel and live in the present. The worldwide flood described in the Bible and its effects on the earth may offer essential clues to explain these split ranges. Of course, many fish were able to survive outside the ark. Even freshwater animals could survive. Many people don't realize that fresh water from rivers like the Amazon can float for years above the ocean without mixing. So freshwater animals could survive the flood in fresh water, floating above the salty ocean water. Many plants that weren't on the ark could have floated during the flood, some even in the floating freshwater. As the floodwaters receded, plants and fish would have been left behind at lakes and other places around the world. Many plants would have continued to float, providing a way to distribute animals after the flood. After Mount St. Helens erupted in 1980, hundreds of thousands of Douglas fir trees were ripped up and remained floating on the lake 25 years later. If Noah's flood ripped up every forest in the world, mats of trees probably stayed afloat for centuries. As winds blew these enormous log mats in circular paths in the oceans, they would have served as rafts for animals to cross oceans. Rafts may also explain how tortoises got to remote islands. Interestingly, most modern animals and plants with ranges split across oceans follow the pattern of modern currents. Their distribution can be explained by rafting. In this way, the flood and its aftermath provide a solution for one of the many mysteries of biology: split ranges. The ice on Greenland and Antarctica is in places miles deep and hundreds of miles wide. In the present, however, all but the edges of these ice sheets are cold deserts. Not enough snow and ice falls there to build up the depth of ice that we find today, even if long periods of time were available. The flood of the Bible may provide an answer. First of all, flood rocks contain thick piles of lava and huge volumes of volcanic ash. Meteorologist Mike Ord has suggested that this might have led to the Ice Age.
There was a lot of warm water added to the pre-flood oceans from the crust, and also a lot of lava flows and volcanism that heat the waters.
Evidence in fossils suggests that the oceans were warmed up in the course of the flood.
The average temperature of the ocean is 39 degrees Fahrenheit. Well, after the flood, it could have been an average of about 86 degrees Fahrenheit. And you could have taken a swim in the Arctic Ocean right after the flood. It was so warm. But then it's going to start cooling down, and that cooling is mainly by evaporation. So the key here is that with that warm water, you evaporate so much more water vapor in the air.
As the oceans cooled after the flood, heavy snow began to fall. Computer simulations that begin with warm oceans show snow falling far inland over cool continents. Ice sheets build up thousands of feet thick, where we see evidence for such ice today. This ice built up in only a few centuries of time. The whole process was sped up by volcanic ash cooling the Earth after the flood.
Because of the instability of the Earth after the flood, there'd be a lot of volcanism. Aerosols are tiny particles about a micron in diameter, and they'll float up there in the stratosphere for several years, and they reflect sunlight back to space. So you have a cooling mechanism. The ice is going to build up, and then finally it's going to come to a point where it's going to peak. That's glacial maximum.
Once the oceans cooled enough, the evaporation slowed, the snows stopped, and the ice began to melt. Calculations suggest that the buildup, movement, and melting of ice did not require many thousands of years as is traditionally taught. From a warm world at the end of the flood to the melting of the ice took only centuries of time.
And then I see evidence of the one ice age and a short, rapid ice age that melts catastrophically. This is what I see based on science.
Present climate is not the key to understanding what produced thick piles of ice in Greenland and Antarctica. It looks like the Bible had the key all along: the Great Flood in the days of Noah.